It can't be that hard. I mean, it's 2 words. Come on, flip the next one. Isaac, I'm getting. Don't get it. I mean, maybe it's animal. Maybe it's a printer. Hey, Kat, what's up? Hey, so I'm doing one of those puzzle games where you have pictures and then it makes a phrase or something silly. Mm-hmm. It's 2 words and I can't figure it out. See, so we've got this, that's the first one, and then that. Right? It's not maybe animal prints, that's what I was going for, but it doesn't like that.
CATSCAN.
CATSCAN. CATSCAN. It's a CATSCAN. You are so smart. And I'm like, oh my gosh, did you know that CATSCANs actually have something to do with NASA? Radiology, the science behind CT scans, dates back to 1896, when Wilhelm Röntgen accidentally discovered X-rays. X-rays work like light, meaning that they are part of the electromagnetic spectrum. X-rays are a shorter and more energetic wavelength than visible light. X-rays are what the X-ray machine is named after. Röntgen was experimenting with electron beams and noticed a glow coming from a fluorescent screen. When he put his hands between a tube and the fluorescent screen, he saw an outline of his bones projected onto the screen. It didn't take long for the medical field to implement X-rays everywhere. This had many long-term consequences, but one of the innovations that built on X-ray technology was computed axial tomography, or the CAT-scan. Godfrey Hounsfield was a British engineer in the 1960s. While on holiday, Hounsfield met a doctor complaining about the quality of brain X-rays. The problem was that brains are dense and contain bones and tissue, which is hard to differentiate on a regular X-ray. Hounsfield's brain scanning method is best explained with food. Imagine the brain as a loaf of bread cut into slices. For each slice, an X-ray travels through it from different angles, up to 180 degrees, measuring how strong the X-rays are after passing through. X-ray strength tells us a little bit about the brain density. Stronger X-rays equals less dense areas, and weaker X-rays equals denser areas. This approach allows for creating detailed images of the brain's internal structure without invasive procedures. And most importantly, Hounsfield wrote an algorithm to combine all of these images together to create a picture. In 1971, Hounsfield and the Atkinson Morley Hospital scanned their first patient. At first, this was a painfully slow process. The scan lasted 30 minutes, and the data processing took nearly 3 hours. And this is where NASA came in. In 1966, Surveyor 1 began a 7 spacecraft mission to photograph the moon. Prior to this, the moon had only had images that were distorted or lopsided. So NASA's Jet Propulsion Lab, led by Dr. Robert Nathan, proposed digital imaging processing software. In simplest terms, this converted analog signals into digital signals that can be enhanced by a computer. It is estimated that these computer enhancements nearly doubled the observable details on the moon. This method of converting analog images to digital and enhancing images has found applications across fields, but particularly in medicine. When applying these enhancements, suddenly those images on CT scans became even more crisp and clear, making these images even more valuable. For more than 50 years, the space and medical fields have been cross-pollinating and sharing ideas to make the world around us better. The equivalent to a giant CT scanner called the ACTIS, or Advanced Computed Tomography Inspection System, is used by NASA's space shuttle engineers to find structural defects in spacecraft components. The ACTIS has also been used in fields such as archaeology to find bones embedded in rock, and by the Department of Energy during inspections of large drums of waste. You see, science doesn't confine itself to just one field at a time. As we learn more about the universe around us, we find direct connections to our lives here on Earth. Thanks for watching this episode of Relatable Space. To find out more about the Apollo missions or space inventions, come join us here at the New Mexico Museum of Space History in Alamogordo.
You know, Maquette, that was actually pretty cool about CATSCANs.
Cute.
But I was kind of hoping for more cat photos.
I think I got you. Ooh.
Catch